Labor costs are a significant factor for electrical contractors, typically accounting for 30% to 50% of total project costs. Efficient labor management is crucial for optimizing profitability and maintaining a competitive edge. In residential electrical applications, industry standards for labor efficiency can vary based on location and project scope. However, general guidelines exist. For an opening, expect approximately 30 to 45 minutes per opening, which includes setting up the work area and basic troubleshooting. For a service call, allocate about 30 to 60 minutes, depending on the complexity of the issue. For rough-in work, estimate around 20 to 25 minutes per outlet box installed, assuming an average-sized home. And for trim-out tasks, plan for approximately 10 to 15 minutes per light fixture or switch installed, considering standard installations. Several factors can affect labor efficiency. Firstly, worker skill and experience play a crucial role. More experienced and skilled electricians tend to work faster or more accurately. Secondly, project complexity influences the time required. Complex projects with intricate wiring or challenging installations naturally take longer. Thirdly, the availability and quality of tools and equipment directly impact efficiency. Having the right tools in good working order saves time and effort. Fourthly, the work environment matters. Factors like accessibility, lighting, and temperature can affect worker productivity. And fifthly, scheduling and coordination are vital. Poor scheduling or lack of coordination can lead to delays and wasted time. To improve labor efficiency, electrical contractors can implement several strategies. Firstly, invest in training and development. Provide employees with ongoing training to enhance their skills and knowledge. Secondly, optimize processes. Streamline workflows, eliminate waste, and minimize unnecessary tasks. Thirdly, improve job planning. Thoroughly plan projects, including accurate material and labor estimations to reduce rework and unexpected delays. Fourthly, utilize technology. Implement software tools for scheduling, project tracking, and communication to improve coordination and reduce manual labor. And fifthly, monitor performance. Regularly track labor metrics to identify areas for improvement and implement corrective actions. Labor is a critical factor in electrical contracting, and efficient management is essential for profitability. While industry standards provide general guidelines for residential applications, contractors should consider their specific circumstances and implement strategies for continuous improvement. When considering electrical services, ensure the correct wire gauge is used to handle the intended amperage to prevent overheating and potential fire hazards. This is a basic but critical safety measure. Overcurrent protection devices, such as circuit breakers and fuses, are vital components in electrical systems. They protect against overloads and short circuits, preventing damage to equipment and reducing the risk of electrical fires. Grounding is another essential safety measure. Grounding provides a low-resistance path for fault currents, helping to trip overcurrent protection devices and minimizing the risk of electric shock. Bonding is related to grounding and involves connecting metallic parts of an electrical system to create a continuous electrical path. This ensures that all metallic parts are at the same potential, reducing the risk of shock. GFCI protection is crucial in areas where water is present, such as bathrooms, kitchens, and outdoor locations. GFCIs detect ground faults and quickly interrupt the circuit, preventing electric shock. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which can be a common cause of electrical fires. RFCIs detect arc faults and trip the circuit, reducing the risk of fire. Electrical panels should be properly labeled to clearly indicate the circuits they control. This makes it easier to identify and to energize circuits for maintenance or repairs. Wiring should be installed according to code requirements, including proper support, spacing, and protection from damage. Safe wiring practices are essential for preventing electrical hazards. Junction boxes are used to enclose wire connections and provide protection from the environment. Junction boxes should be properly installed and accessible. Electrical permits are typically required for electrical work to ensure compliance with safety codes and regulations. Always obtain the necessary permits before starting any electrical project. Qualified electricians should perform electrical work to ensure it is done safely and correctly. Improperly performed electrical work can be dangerous and may not meet code requirements. Regular inspections of electrical systems can help identify potential problems before they become serious. Schedule regular inspections by a qualified electrician. Extension cords should be used only temporarily and should not be overloaded. Avoid using extension cords as a substitute for permanent wiring. Surge protection can help protect electronic equipment from voltage spikes caused by lightning or other electrical disturbances. Consider installing surge protection devices. Smoke detectors are essential safety devices that can alert you to a fire. Install smoke detectors on every level of your home and test them regularly. Carbon monoxide detectors are also important for detecting carbon monoxide, a deadly odorless gas. Install carbon monoxide detectors and test them regularly. When working on electrical systems, always to energize the circuit before starting work. Use a voltage tester to verify that the circuit is de-energized. Use appropriate personal protective equipment, such as gloves and safety glasses, when working on electrical systems. Proper personal protection can reduce the risk of injury. Be aware of overhead power lines when working outdoors. Maintain a safe distance from power lines to avoid electrocution. Avoid using water near electrical equipment. Water can conduct electricity and create a shock hazard. If you are unsure about any aspect of electrical work, consult with a qualified electrician. It is always better to be safe than sorry. Understanding electrical safety is essential for preventing electrical hazards and protecting yourself and your property. According to the National Electrical Code, Section 210.8, ground fault circuit interrupter protection is required for all 120-volt, 15 and 20 amp receptacles installed in bathrooms. The NEC, Section 210.12, requires arc fault circuit interrupter protection for branch circuits that supply outlets and dwelling units. NEC Article 310.15 provides guidance on the ampacity of conductors, taking into account factors such as conductor size, insulation type, and ambient temperature. According to NEC Table 250.122, the size of the equipment grounding conductor is based on the size of the overcurrent protective device. NEC Section 406.4 requires that receptacles installed in damp or wet locations be protected by a weatherproof enclosure. According to NEC Article 430, motors and motor circuits must be protected against overload and short-circuit conditions. NEC Section 517.13 covers the grounding and bonding requirements for healthcare facilities to ensure patient safety. NEC Article 547 provides requirements for agricultural buildings addressing the unique electrical hazards in these environments. NEC Section 680 covers the requirements for swimming pools, spas, and hot tubs to prevent electrical shock hazards. According to NEC Chapter 9, wiring methods must be suitable for the environment in which they are installed. The purpose of the NEC is to protect people and property from electrical hazards. The NEC is updated every 3 years to reflect changes in technology and safety practices. Local jurisdictions may adopt and amend the NEC to meet their specific needs. Understanding the NEC is essential for electrical contractors and anyone working on electrical systems. Always consult the latest edition of the NEC for the most up-to-date requirements. The NEC is not a substitute for proper training and experience. Electrical work should only be performed by qualified individuals. According to the NEC, all electrical work must be performed in a neat and workmanlike manner. The NEC requires that electrical equipment be listed and labeled by a recognized testing laboratory. The NEC provides requirements for the installation of electrical equipment in hazardous locations. The NEC requires that electrical panels be accessible and have sufficient working space. The NEC provides requirements for the identification of electrical conductors. The NEC requires that electrical boxes be properly supported and secured. According to NEC Section 110.12, unused openings in electrical boxes and cabinets must be closed. The NEC requires that electrical splices be made in an approved manner. The NEC provides requirements for the protection of electrical wiring from physical damage. According to the NEC, electrical equipment must be installed according to the manufacturer's instructions. The NEC requires that electrical systems be tested and inspected before being placed into service. The NEC provides requirements for the maintenance of electrical systems. According to NEC Section 90.4, enforcement of the NEC is the responsibility of the authority having jurisdiction. The NEC is a living document that is constantly evolving to address new challenges and technologies. Understanding and applying the NEC is essential for ensuring electrical safety and preventing electrical hazards. Always consult with a qualified electrician or electrical inspector if you have any questions about the NEC. The NEC is a valuable resource for anyone involved in electrical work. According to NEC Section 210.52, receptacle outlets must be installed in dwelling units so that no point along the floor line in any wall space is more than 6 feet from an outlet. NEC Section 250.50 covers the requirements for grounding electrode systems. NEC Article 300 provides general requirements for wiring methods and materials. NEC Section 314.16 provides requirements for the number of conductors allowed in outlet device and junction boxes. According to NEC Section 408.3, overcurrent protection devices must be readily accessible and not exposed to physical damage. NEC Article 440 provides requirements for air conditioning and refrigerating equipment. NEC Section 500.5 covers the classification of hazardous locations. According to NEC Article 514, gasoline dispensing and service stations have specific electrical requirements due to the presence of flammable liquids and vapors. NEC Section 517.10 covers the general installation and grounding requirements for healthcare facilities. NEC Article 600 provides requirements for electric signs and outline lighting. According to NEC Section 625.1, electric vehicle charging systems must comply with specific safety requirements. NEC Section 640.1 covers audio signal processing, amplification, and reproduction equipment. According to NEC Article 645, information technology equipment rooms have specific electrical requirements to ensure safety and reliability. NEC Section 647.1 covers sensitive electronic equipment such as in computer rooms or industrial facilities that require special grounding and bonding. According to NEC Section 690.1, solar photovoltaic systems must be installed in accordance with specific safety requirements. NEC Article 700 covers emergency systems, which are essential for providing power during power outages. NEC Section 701.1 covers legally required standby systems, which provide power to critical loads during power outages as mandated by law. NEC Article 702 covers optional standby systems, which provide power to non-essential loads during power outages. According to NEC Section 705.1, interconnected electric power production sources must be installed in accordance with specific safety requirements. NEC Section 725.1 covers remote control, signaling, and power-limited circuits. NEC Article 760 covers fire alarm systems, which are essential for detecting and alerting occupants to fires. According to NEC Chapter 8, communication systems, such as telephone and data networks, must be installed in accordance with specific safety requirements. NEC Chapter 9 contains tables and examples that are helpful for calculating conductor ampacity, box fill, and other electrical parameters. According to NEC Section 110.3, examination, installation, and use of equipment must be in accordance with the manufacturer's instructions. NEC Section 200.4 covers the identification of grounded conductors, typically identified by a white or grey color. NEC Article 215 provides requirements for feeders, which are the conductors that supply power from the service equipment to branch circuit panels. NEC Section 220.12 provides requirements for general lighting loads and dwelling units based on the square footage of the building. According to NEC Section 225.30, outside branch circuits and feeders must be installed in accordance with specific safety requirements. NEC Section 230.40 provides requirements for service entrance conductors, which connect the utility power supply to the building's electrical system. NEC Article 240 provides requirements for overcurrent protection, including circuit breakers and fuses. According to NEC Section 250.24, grounding of service-supplied alternating current systems is essential for safety and proper operation of electrical equipment. NEC Article 250 provides comprehensive requirements for grounding and bonding, which are critical for preventing electrical shock and fire hazards. NEC Section 300.11 covers securing and supporting wiring, ensuring that conductors are properly installed and protected. According to NEC Article 310, conductors for general wiring must be selected based on their ampacity, voltage rating, and suitability for the environment. NEC Section 312.5 covers cabinets, cutout boxes, and meter socket enclosures, providing requirements for their installation and use. NEC Section 314.27 covers outlet boxes, providing requirements for their installation and use in various applications. According to NEC Section 330.30, metal-clad cable must be properly supported and secured to prevent damage and ensure safety. NEC Article 334 covers non-metallic sheath cable, commonly known as Romex, providing requirements for its installation and use in residential wiring. NEC Section 340.30 covers underground feeder and branch circuit cable, providing requirements for its installation and use in underground applications. According to NEC Section 350.30, flexible metal conduit must be properly supported and secured to prevent damage and ensure safety. NEC Article 352 covers rigid polyvinyl chloride conduit, providing requirements for its installation and use in various applications. NEC Section 356.30 covers liquid-type flexible metal conduit, providing requirements for its installation and use in wet locations. According to NEC Section 358.30, electrical metallic tubing must be properly supported and secured to prevent damage and ensure safety. NEC Article 360 covers flexible metallic tubing, providing requirements for its installation and use in dry locations. NEC Section 362.30 covers electrical non-metallic tubing, providing requirements for its installation and use in dry locations. According to NEC Section 366.30, auxiliary gutters must be properly supported and secured to prevent damage and ensure safety. NEC Article 368 covers busways, providing requirements for their installation and use in industrial and commercial applications. NEC Section 370.30 covers cable trays, providing requirements for their installation and use in supporting cables. According to NEC Section 372.30, cellular metal floor raceways must be properly installed and used in accordance with the manufacturer's instructions. NEC Article 374 covers cellular concrete floor raceways, providing requirements for their installation and use in concrete floors. NEC Section 376.30 covers metal wireways, providing requirements for their installation and use in surface-mounted applications. According to NEC Section 378.30, non-metallic wireways must be properly installed and used in accordance with the manufacturer's instructions. NEC Article 380 covers switches, providing requirements for their installation and use in controlling lighting and appliances. NEC Section 382.30 covers multi-outlet assemblers, providing requirements for their installation and use in providing multiple outlets along a wall. According to NEC Section 384.30, surface metal raceways must be properly installed and used in accordance with the manufacturer's instructions. NEC Article 386 covers surface non-metallic raceways, providing requirements for their installation and use in surface-mounted applications. NEC Section 388.30 covers underfloor raceways, providing requirements for their installation and use underfloors. According to NEC Section 390.30, undercarpet cable must be properly installed and used in accordance with the manufacturer's instructions. NEC Section 392.10 covers cable trays, providing requirements for their installation and use in supporting cables. According to NEC Section 393.10, low-voltage suspended ceiling power distribution systems must be properly installed and used in accordance with the manufacturer's instructions.